All right, on this lesson, we're going to be solving equations again, but this time it's going to have rational exponents. So remember, rational means fraction. So we will have fractions as our exponents. We discussed this before. Recall the relationship between radical expressions and rational exponents. This relationship may be applied to solving radical equations, which we've been talking about, or solving equations involving rational exponents. So radical expressions may be written with rational exponents. We've talked about this before. If you have a radical, you can change it to a rational exponent. So if you don't remember, the exponent stays there, the index becomes the denominator, and vice versa. So if you have your rational exponent, you can rewrite it as a radical. So it says the index of the radical becomes the denominator of the exponent. So your process for this is to isolate your term that is raised to the power. After you do that, to get rid of that exponent, you're going to raise both sides to the reciprocal power. So you're going to flip it. So flip that fraction. And then you're going to raise it to both sides. Now, one thing that you have to remember when you're dealing with rational exponents is anytime we take the square root of both sides, remember we've discussed it before, like this example, we get two answers. So it says use plus and minus to represent the solution. If both sides are raised to an exponent with an even, so like 2, 4, 6, 8, 10, so an even denominator while solving, okay? So if you end up with, once you raise both sides to the reciprocal power, if the denominator is an even number, then you'll have a positive and a negative, and it explains it right here. So first step, I like to, just like the radical term, I like to circle whatever is raised to the rational exponent. Don't circle anything that's not. So first step is to isolate it. So I need to add 1 to both sides first. And then I divide by 2. I don't distribute the 2. And then once I get to this point, this is when, to get rid of that rational exponent, I'm going to raise it to the reciprocal power. So I'm going to raise both sides to the 5/4 power. Those cancel out because you would get 20 over 20, which is 1. So I'm left with x plus 3. And then right here, notice this denominator is an even number, which means you'll have a positive and a negative answer. So I'm going to go ahead and put a positive and negative here. I'm going to rewrite this rational exponent with a radical. So I'm going to make that my index. So I'm going to take the 4th root of 16 and then I'll raise it to the 5th power. So that denominator becomes your index. That 5 stays there as the exponent. So we need to simplify that. So right here, 4th root of 16. If you don't remember how to do that, you're using factor tree 2 times 8, 2 times 4, and 2 times 2. So that's 4. It's perfect. So the 4th root of 16 would be 2. And then I'm having to raise it to the 5th power. So 2 times 2 times 2, 5 times would give us 32. So I isolate my x by subtracting 3. Now you're going to be getting 2 answers here. So make sure that you add or you subtract 3 from positive 32, which would give you 29. And then you do negative 32 minus 3, which would give you negative 35. So we get 2 solutions here because this right here was even. So if that denominator, when you raise both sides to the reciprocal, is even, you get 2 answers. All right, so now I need to check for extraneous solutions. So we went over that on the last lesson. We have to plug it in and make sure that since we're dealing with radicals and square roots, 4th roots, and so on, that it works out. So again, you can use a calculator when you do this. Just make sure that you're plugging in to the original equation. So again, you can use a calculator when you work this one out. I'm just going to save some time. It works out. And then you have to also check the negative 35. So just plug it in the calculator if you're using it. Plug again exactly as you see it. So that one also works out. So we have two solutions on this one, 29 and negative 35. So this is solving a equation that has a rational exponent. So really it's the same thing as solving radical equations because we can rewrite it with a radical. Okay, looking at the next example, we want to isolate whatever is raised to the rational exponent. So I need to subtract 5 first. That's x minus 4 to the 3 halves equals 13 minus 5 is 8. Once I've isolated it, I need to raise it to the reciprocal power to get rid of it. Make sure you do the same thing to the other side. Those cancel. We're left with x minus 4. Now notice right here this denominator is odd, which means you do not need a plus and a minus. So I'm going to rewrite this. Remember, this is my index, so I'm going to take the cube root of 8, and then I have to square it. So cube root of 8, you should be able to do this in your head, is 2, but 2 squared is 4. So we add 4 to both sides, and we get x equals 8. So we just get one answer here, so we need to check it. Again, you can use a calculator to check it. Just plug in that x value in for x on your original equation. And again, in order to save some time, I'm just going to let you know that it works out. So x equals 8. All right, let's take a look at this third example. So again, first step is to isolate whatever is raised to the rational exponent. So my base is x plus 3. Notice it's already isolated, so I can go straight into raising it to the reciprocal power. The reciprocal of 1/2 is 2 over 1, but I would highly recommend just putting a 2 there. So it's the same thing. So I'm going to square both sides. Now, you had this on another example on another lesson, and then also on an assignment. Make sure when you have a binomial that is squared, you write it twice and you use FOIL. That's x squared minus 3x plus 9. So you get x squared minus 6x plus 9. So again, when you square a binomial, you should get a trinomial. So now notice when we squared both sides, we ended up with a quadratic equation. So I'm going to set it equal to 0. Again, we've already discussed all the different ways of solving a quadratic. You can use whatever method you prefer. So remember, quadratic formula works every time, so you're welcome to do that. So that's x equals negative b, so 7 plus or minus the square root of negative 7 squared minus 4. A is 1, c is 6, all over 2 times a, which is 1. So you want to, then if you're using the quadratic formula, you're going to plug in what's under the square root. So make sure if you are doing that or using the calculator to help you out, make sure that you put parentheses around the negative 7 before you square it, or it will give you the wrong answer. So if you plug that in without the square root, you get 25, which would square root of 25 is 5. And we need to separate it and find our two answers. So 7 plus 5, which is 12, divided by 2 would be 6. And then 7 minus 5 is 2, divided by 2 is 1. So we get two solutions, x equals 6 and x equals 1. We need to check both of them. Again, I don't care if you use a calculator to help you check. Make sure that you're plugging it in to both sides of the original. So I'm plugging in a 6 first. So when you plug in the 6, again, you can use a calculator. That one works out. And then if you're plugging in the 1, it does not work out. So the only solution would be x equals 6. Okay, so this is solving radical or rational exponent equations. So if you have any questions, please let me know. Make sure you're always checking to make sure that they work out.